You know that feeling, right? You ask an AI a perfectly simple question, and it gives you this incredibly confident, detailed answer that is just completely wrong. It's a bizarre thing that AI models do, making stuff up out of thin air. It's called hallucination, and today we are going to pull back the curtain and figure out exactly why it happens. All right, let's just jump right in with a real-world test case from the research paper we're looking at today. They posed a super simple, factual question to a top-tier language model. What is Adam Tauman Kalai's birthday? I mean, it seems easy enough, doesn't it? Well, here's what happened. On 3 different tries, the AI gave 3 completely different, very specific answers. July 3rd, then June 15th, then January 1st. And here's the kicker, his actual birthday's in the fall, so all 3 were dead wrong. This right here, this is the mystery we're going to solve today. So this behavior, just inventing these plausible sounding but totally false bits of information, that's what the experts call a hallucination. And it's not just some funny little quirk, It's a really fundamental problem that makes it hard to trust these systems. So let's start our investigation into why these AIs are such convincing liars.
And believe me, it is not just a one-off thing with birthdays. This problem is absolutely everywhere. When researchers asked for the title of Adam Kalai's dissertation, 3 of the world's biggest AI models, we're talking ChatGPT, DeepSeek, and Llama, each one just made up a different, super specific, and honestly, very believable sounding title. And of course, none of them were even close to correct.
And this is where it gets, well, kind of weird. This example really shows you how deep the rabbit hole goes. So the researchers asked the DeepSeek model a ridiculously simple question. How many letter Ds are in the word DeepSeek? You'd think it would know that, right? I mean, it's its own name. But nope, over and over again, it would say 2 or 3. Other models even guessed 6 or 7. When an AI can't even get that right, you know something really fundamental is off. So where in the world do these confident lies come from? Well, the first clue is actually in how these models are born in the first place. It's all about their upbringing, that initial phase where they learn from just unimaginable amounts of text from the internet. The researchers have this really great way of thinking about it. They call it the is it valid problem. Basically, you can imagine an AI's entire training is just one giant game of true or false. It sees billions of examples, and its only job is to learn the difference between a valid statement, like correct grammar, and an error. And here is the absolute key to this whole thing. It is one thing for an AI to see the sentence, the sky is blue, and go, yep, that looks valid. But it is a completely different and way, way harder challenge to generate that fact from absolute scratch. Generating forces the model to do more than just recognize a pattern. It has to make a statistical bet.
And this right here breaks down exactly how that bet leads to a lie. So here's how it goes down. First, the AI gets amazing at things that follow rules and patterns, like grammar. But for a random fact, like someone's specific birthday, there's no pattern to learn. It's just a fact. So without a rule to follow, its only move is to make a statistical guess based on all the other names and dates it's ever seen. And boom, that's the exact moment a hallucination is born.
The paper even gives us a way to measure this, and it's a fascinating idea. It's called the singleton rate. What it says is if 20% of the birthday facts in all of its training data are singletons, meaning they only show up one single time, then you should statistically expect the model to hallucinate on at least 20% of new birthday questions. I mean, think about that. The rarity of the information directly predicts how often it's going to lie. Okay, so the models are basically built to make things up when they're not sure. But why aren't we training this out of them? Why aren't we fixing it? Well, that brings us to the second part of our investigation, the AI's schooling, or, how we test it. And the researchers offer up this perfect analogy that just makes everything click into place. They say language models act just like students who are taking a really hard, high-stakes exam. When they hit a question they don't know, what's the smartest strategy to get the best possible score? This slide just lays it out so perfectly. Imagine 2 students. You've got the honest student who, when they're unsure, just writes, I don't know. What do they get? A guaranteed 0 for that question. But then you've got the savvy test taker. They're also unsure, but they make a good, plausible guess. Yeah, they might be wrong and get a 0, but they also have a shot at being right and getting a point. If the test is just scored right or wrong, guessing is always the winning strategy. And this, right here, this is the smoking gun. This table shows the major AI benchmarks. These are the exams we use to decide which AI is the smartest. Just look down that list: GPQA, MLLU Pro, IFAVEL. They all use simple, binary, 0 or 1 scoring. They give 0, absolutely no credit for just admitting you don't know. We are actively rewarding our AIs for guessing. We've been training them to be savvy test takers, not honest partners. So the bottom line is, because of the way we grade them, these models are basically stuck permanently in test-taking mode. They are always incentivized to bluff, to guess, to just make something up, because for years, that is the exact behavior that has gotten them the highest scores on our tests. But this all leads to a really surprisingly hopeful conclusion. To fix this whole hallucination problem, we might not need to totally reinvent AI from the ground up. We might just need to fix the test. So how do we actually do that? Well, the paper lays out a super clear path. We just have to change the rules of the game. Stop with the simple right or wrong scoring. Start giving partial credit for an honest, I don't know. Introduce actual penalties for getting it wrong, and, critically, tell the AI what the new rules are, right in the prompt. And this is a brilliant example of what that actually looks like. Imagine just adding this one sentence to a question. All of a sudden, the entire incentive structure flips on its head. Guessing is now a super high-risk, low-reward strategy. The AI is now rewarded for what we actually want, accurately judging its own confidence and being honest when it doesn't know. So really, this is what it all comes down to. We have spent years and, frankly, billions of dollars training AI to be the perfect test taker for the flawed exams that we ourselves created. The real challenge now is to change the test. And by doing that, maybe we can teach our AIs something far more valuable for the real world. The simple wisdom and the honesty of just saying, I don't know.